Welcome back, and today we're going to build off yesterday's lesson of solving equations with variables on both sides by figuring out what do we do if there's a distribution situation. For example, 7 times negative 6x minus 6 equals 3 plus 3x. I'm going to tell you right now, usually it's best to distribute first. So that's kind of our one step, or the first thing we're going to do. So it's usually best to distribute first. So we're going to take care of that. We are going to distribute our 7 into the parentheses, and we've got ourselves negative 42x minus 42 equals 3. Oh my, that equals is not the greatest. Let me fix that. It's like 2 equals 3 plus 3x. Now, once you get to here, you got to use the rules we talked about yesterday, which is move the smaller variable term to the bigger variable term side. And this guy, negative 42x, is technically smaller than this guy, okay? Because it's kind of a bigger negative number. So we want to move the negative 42x. Opposite of minus 42x is plus 42x. Those guys cancel. Make sure we line up our terms, our like terms, to make it easy to work with. And we've got negative 42 equals 3 plus 45x. And from here, we just want to get our variable term by itself. So I'm going to minus 3 both sides. We've got negative 45 equals 45x. And last but not least, we divide both sides by 45. And we've got negative 1 equals x. Boom. There we go. Let me do 2 more with you guys. But that's, I mean, really the only thing we've added is that distribution part up top. If you can jump from here to here, then you're back to what we did yesterday, which is get your variables on the same side of the equal sign and then solve. So let me get one more with you guys right here. What if I do n plus 23 equals negative 2 times 6 minus 3n? Well, first step is always going to be distribute. I shouldn't say always. It's distributing is probably best most of the time. N plus 23 equals negative 2 times 6 is negative 12. Wow, that 12 had a tough time. Negative 12. And negative 3 times a negative 2. So we got negative 2 times negative 3n is positive 6n. Once we get to here, we're moving our smaller variable to the bigger variable's side, and that would be this n. Remember, sometimes when people minus n, they'll just cancel the n. We don't want to do that. Remember, there's an invisible 1 right before that n. So I'm going to minus 1n from both sides. Wow. I'm going to minus 1n from both sides. Minus 1n. If we write that 1 in, it's easier for our brains to see, oh, we're doing 6 minus 1. I know what that is. That's a 5. And then, of course, we've got negative 12, and we've got 23 right there. And from here, two-step equation, we want to get our variable term by itself, which is this guy right here. So then we're going to plus 12 both sides to get rid of that. We've got 35 equals 5n. And last but not least, we're going to divide both sides by 5 to get our n totally by itself. We've got 7 equals n. Done. Whoosh. So that problem uses that invisible 1. Again, if you see a variable by itself, I find it easiest to put a 1 in front of that variable by itself, so we really know there's a 1 before it. Now, there's one more thing I want to show you guys. This is optional, of course, but we're going to call it our power move. Boom. And remember, this is optional. You do not have to do this, okay? Because what we can do, if we go 4 minus 4x equals negative 2 times 8x plus 4, we're going to solve this the same way as normal, which is distribute the outside negative 2. So I go 4 minus 4x equals, let's see, distribute this guy. We have negative 16x, and we have negative 8. The power move happens right here. We know the step we're supposed to do next is to get our variables on the same side by moving the smaller, or in a way kind of more negative number, which in fact is this guy. So we're going to move that guy. Now normally we'd go plus 16x plus 16x and kind of solve that part. The power move is you need to understand, oh, I'm canceling on this side, so I'm going to move this number to the other side using inverse operations. So we're going to do a minus 4 at the same time. So we cancel both our variable on one side and our number on the other using this power move. So now we can go, okay, negative 4x plus 16 is 12x, and this guy's negative 12. From here, divided by 12 both sides, and we've got x equals negative 1. Boom. Do you have to use the power move? No, it's just pretty much 2 steps in one. If we look up here, you're seeing we moved our variables first and then our numbers. This step, we're moving our variables and our numbers at the same time. The thing you have to understand about the power move, though, is where the pieces go. You have to understand that, okay, we're going to cancel this term, and because we're canceling the term over here and moving the variables to this side, we need to move this number to the other side, also using inverse operations. So you have to understand why you're doing what you're doing in order to do the power move. Anyway, hopefully that helped.